In this module, we're going to talk about performance optimization and what tools we can use to help us measure things to be optimized. The advice here is if you want to optimize something, you should measure it first and measure it after the optimization, because otherwise you don't really know if your optimization actually made things better. In a React application, most of the optimization concerns happen during the update operation of a component. The component lifecycle methods help us identify any areas in the code that could use some optimization. So let's make sure we understand those first. There are 5 lifecycle methods that apply to an update process in a React component. Component will receive props, which has an argument of those next props that are received. Every time the parent component re-renders a child component, the component will receive props is invoked with the new passed-in props, even if those props are identical to the current props. So a call to component will receive props does not really mean that the component is going to re-render. Also, if the component sets its state internally, this would generally not trigger the component will receive props lifecycle method. So this method is actually not super useful for performance analysis. Should component update has 2 arguments of the next props and the next state for a current update operation. This lifecycle method is very important because we can actually use it to cancel an update process. Returning false from this lifecycle method tells React to not re-render the component at all. This is very useful for pure components. If the component is being passed the exact props and state, and we know it's pure, which means its output will be exactly the same, we can use an if statement in a shouldComponentUpdate lifecycle method to compare current and next props and state and return false if they're the same. That's exactly what the React pure component class does. However, in some cases, we might need different logic to short-circuit the React re-rendering process based on other conditions. We'll see an example of that in this clip. The other lifecycle method that's helpful when analyzing why a component has re-rendered is component will update, which is reported immediately before the rendering step. If we expect a component to not re-render, this lifecycle method should not be invoked. Also, if this lifecycle method is being invoked while the rendered output is exactly the same, we basically have a wasteful render. Let's see an example of that. Let's work with the search bar component. The search bar component is a regular component. So I'm going to go ahead and define should component update, and I'll just return true here. And I'll also define component will update. And in here, let's just have a log statement updating search bar. Very simple. Let's test that. So every second, we are updating search bar. However, we don't really need to update search bar at all. Search bar doesn't need to be re-rendered every second. It's being re-rendered because the global state is changing and the app component is re-rendering, and that makes it re-render all the children component, including search bar. So in should component update, if we just return false in here instead of true and retest now, the search bar component is not being re-rendered at all, right? Because we're short-circuiting the update process for that search bar component. However, that means we can't also type in the search bar component because it's not going to re-render at all. So to fix the problem without breaking the search bar component, we would compare next props with current props and next state with current state, and return false if they're exactly the same. And that's actually what React pure component does. So we can just use pure component here. So let's test that. With a pure component, the search bar is not re-rendering, but we can type in it. And when we type, it re-renders, right? Because we typed 6 letters, it re-rendered 6 times. But that's about it. It doesn't re-render every second. So here's my advice. Always use pure component unless you have a reason not to. Okay, so let me clear that up. And now let's target another component. Let's target the timestamp component. Same thing. We will do a should component update in here and just return true. And the component will update lifecycle method and console log updating timestamp. Let's take a look at that. And the timestamp component is getting updated every second, which is actually a valid case, right? Because we are updating the timestamp every second. So in this particular case, React pure component doesn't add any value really because we are updating the component every second. However, if this component is being updated for different reasons other than the every second update, then a pure component would help. But we're going to need to dig deeper to know if the component is being updated for different reasons. However, let's assume that this timestamp component is needed to render only the time part, not the date part, and actually not include the seconds, just hours and minutes. In that particular case, I don't need the timestamp component to re-render every second. I just need it to re-render every minute. So let's test that. We can simply make the timestamp component renders just the hours and minute using this expression, which I totally got out of Stack Overflow. So this casting method takes a second option here, and we can specify what to display in there. So we have hour and minute only now. And if we re-render the timestamp component now, we see just hours and minutes, but the timestamp component is still ticking every second. So actually 59 of those update operations are going to be wasteful. We don't need the component to re-render every second. We just need it to re-render every minute. Here's the thing. Even if I converted this component to a pure component, that's not going to help me. I'm going to comment out should component update and leave it just to pure component and see if that's going to help me. Will it? It will not. It's still ticking every second. Why? Because actually our next prob as read from store is going to be different. We are receiving a different timestamp. However, we're only displaying just the hours and minutes of that timestamp. So we have two solutions here. Either we'll make the container component pass just the hours and minutes and just display that, which is actually really simple to do. We just move this method into here, and let's test that. So now it's not re-rendering every second because the prob itself is being passed differently, and the pure component is doing its thing here and saying, I don't need to re-render. But let's assume this wasn't an option. I need the timestamp value to be passed to the timestamp component, and I need the render method to cast that value into just the hour and minute string. What can we do to make the component not re-render every second? We can use a custom should component update. We can do something like the current time display, which is what we're rendering, and the next time display is the exact same statement, but instead of this dot props, next props, just like that. And we can return current time display does not equal next time display. So if what I'm displaying next is different than what I'm displaying currently, go ahead and re-render. Otherwise, don't re-render. So we can test that. And now my time component rendered the hours and minute, and it's not being re-rendered every second. And that happens thanks to the custom condition that we just added in should component update. And when the minute ticks, we'll go ahead and actually update the timestamp because the next timestamp display is different than the current timestamp display. So that's a valid case for some custom logic inside your should component update. Unless you don't want the actual timestamp value in the timestamp component, and you can just pass it what it needs to re-render. Of course, in here, we are repeating this logic, so we should probably extract it into a function. So I'm going to go ahead and do that off camera. So we now have a time display function that returns the string that we are interested in, and we are using this time display function in the render method. And in should component update, we are comparing the time display for the current timestamp with the time display for the next timestamp. And if they're the same, we don't need to update. So let's test one more time and make sure the timestamp component is rendering and it gets updated when it needs to, but not all the time. So we didn't use the next state here. We can remove that. And also we can remove the well component update. So I'll leave this in the code as an example of an actual use case for should component update with some custom logic. But again, this is probably not the best way to do that. This is just an example.